How you doing, guys? Today I'm going to talk to you about an Arduino project that I did. We're going to be using a microphone to pick up sound, transmit that data wirelessly, and then display something on another Arduino. So basically, I made a sound sensor with wireless transmission. I'm going to show you what I used. That's the microphone I used. It's from Adafruit.com. This one has automatic gain control. The gain can be set to be 40 dB, 50 dB, or 60 dB. It's a great little microphone. I tried a different microphone first. I tried this one here from Sunfounder. Now, I don't know if it just got banged up when it was sent to me, but I couldn't get analog output out of it. I got digital output out of it, but I couldn't get analog. And it has 4 pins on there. Analog out, ground, VCC, and then digital out. And it's got this potentiometer on here to where you're supposed to be able to adjust the gain. I couldn't get it working, at least not for what I wanted. I could have gotten digital output out of it. I wanted analog output, so that didn't work. So I spent a little bit of extra money, got the one from Adafruit, and it works perfect. Here is the nRF24L01 wireless transceiver. It works at 2.4 gigahertz. It is an awesome little chip, awesome little device. I was originally trying to do this project with XBs, which I have right here. These are the XB Series 2s, and in order to configure them with the XCTU software, I got these also from Adafruit. None of this stuff comes on here, by the way. If you get these adapters from Adafruit, be aware that you have to know how to solder, because none of the resistors, the capacitors, the LEDs, none of the pins, it's just a board and a bunch of pieces. So you got to know how to solder to put this together in order to configure it. But when I tried to use the XBs, I had a hell of a time trying to get the data out of the transmission. Admittedly, I am a novice when it comes to coding. I'm a novice when it comes to wireless things. I'm new to a lot of this. So I was getting the packets of information. I could display the whole packet, but I just couldn't figure out how to get the data and do what I wanted with it. So after a few frustrating days, I just kind of gave up with the XB. And then I think I broke one of them, which I'm not that happy about, but it was okay, because I had these handy dandy nRF24L01s to go to, and they work great, and there's some great libraries out there for them. There is the MIRF or MRF library. That's not the one I used. I used the, I believe it's RF24 library from Maniac Bug, and I'll put the links to both those libraries in the description. And I'll show you the code here in a minute too that I used, and the websites that I used with the how-tos and everything, and it was really simple. Within a couple of hours I had pretty much the whole thing done. I'm going to be using just a 9-volt battery with a hookup for the Arduino for the one that's going to be wireless, the actual microphone itself. And then at the other end, attached to my laptop by USB, I'm going to have this one. Here's the other one. And just a series of LEDs that are going to light up with some resistors, and these are all just working off, various digital pins that aren't being used up by the wireless transceiver. And I'll show you all the hookups for this too. Those are also on the sites that I used. A lot of the stuff, is readily available on the internet. I'll show you how it works real quick. The code is obviously already on them. So this one is just the battery, the microphone. I've tried this through different locations in my house. It works when I'm upstairs and it's downstairs. It works when it's in the next room. I've heard of some videos people say I can go downstairs in my building and it'll work, but then when I try to use it in the room next door, it won't work. I haven't had any of those problems. It's working for me thus far, which is great. So that side's got the battery hooked up. This side I'm just going to hook up to my laptop. There you go. As you can see, the LEDs are going up and down with the sound of my voice. I find that they work a lot better when the noise that you are trying to pick up has some bass to it. The whole idea for this project, it was a school project, and I was going to be designing a baby monitor. There's not a lot of bass in my baby's cry, obviously, but it works nonetheless. When she gives out a wail, it works fine. It goes all the way red, which is what I wanted. But if I were to snap my fingers, it doesn't work that great. I got to snap it pretty hard and pretty close to the microphone in order for it to pick up. So I'll dive in and I'll show you guys the code. Alright guys, so before I get into the code, I just wanted to show you this site here. This is where I got most of the information for my setup, the example code that I used, which I modified to do what I wanted it to do. So it's got a bunch of things in here. It talks about the range of these modules. It says up to 200 feet or 100 meters. Right here is where, I don't know if I mentioned it in the original screen, but where you put the 0.1 microfarad to 10 microfarad capacitor directly on the module from 3.3 volts to ground. This is because they were having current surge problems, so that's why I had that capacitor on there. So if you're going to be using these things, it's probably a good thing for you to think about. They have a link to the data sheet here, which I'm not going to show you, but it's a fairly long document, and if you want to, I mean, I skimmed through it, but it's kind of a lot to take in. These are some of the other ones that they have out there where basically the same thing, only this one has longer range capabilities, obviously, with the external antenna and all that. Then it gets to this part. So this is a top view of the transceiver module, and it's got these hookups here where it shows you what all the pins are. These are the pins here. So you got ground, VCC, CE, CSN, SEK, which is, I believe, the clock, master out, slave in, master in, slave out, and this 8-pin here, I believe, is used for the interrupts, which I didn't use any, so I didn't need it. And then it goes on to show you the different places where you should hook the module up. I mean, it has pins for which library you're using. If you're using the nRF24 library, which is the one I use, the MRF library, for Arduinos, for Megas. So really a lot of good information on here. If you're going to use these things, I highly recommend you check it out. Again, I'll put the link in the description. Then it's got a bunch more notes. These VCC connections must go to 3.3 volts, not 5 volts. The Arduino itself may run at 5 volts and the signal will be okay. The chip is a 3.3 volt device, blah, blah, blah. And then it gives you the link here. Let's click here to get Maniac Bug's excellent RF24 library, which I did. And then it even gives you information on how to install libraries if that's not something you're familiar with. It's a pretty simple process. And it has a MRF library example down here. And then it gets down to this example Arduino sketches, which I will show you now. Alright, so this code here on the left is my transmit code. So this is the one that actually has the sound sensor hooked up to it. And this code here on the right is the code for my receiving Arduino, which is getting the information, doing some logic to it, doing the math to the signal that I need to do to get it to a voltage that I can use for that logic. And I'll just run through it real quick, which they actually have a link to that site in the code itself. So it tells you all of your pinouts here, where to hook them up on the Arduino. And a lot of these, they can be anything. I think the CE and CSN, actually I think all these pins can be anything. I don't think they have to be these pins. I believe they can be changed. And it goes through the libraries you're going to need. You're going to need the SPI library, the nRF24L01, and the RF24. These are both included when you go to Maniac Bug and you get the download. Then you're going to define some pins here. So in order really to get these things working, you just have to define your CE pin, you have to define your CSN pin, and then you define your analog pin, and then you build a pipe. This is a pipe where your information is going to get transmit. Really, it can be any sort of address. I believe it's just got to be the same for the two transceivers. So this could be a number of different things. It doesn't have to be something particular. Obviously, it's a hex value there, starting with the 0x. Then you declare a radio, which is a constructor that is a part of the library. Again, the library is very easy to navigate, easy to use, easy to understand. So you're just creating a radio from your pins that you declared up above. And then I'm beginning the serial, beginning the radio, open the writing pipe, and then you're just taking analog readings from the sensor and then writing them to the radio. And that's it for the transmit part. For the receive part, all of the top bits are pretty much the same. I have a bunch more things to declare here with my LED pins and things like that. Sample window and sample, those are things I'll show you later that I used. But they still have the defines for the CE pin and the CSN pin. Same pipe address here for that constant. Building, again, creating a radio. This is an array that just holds the values, and then begin the serial. There's a 1 second delay. It says that the receiving has been started. Begin radio, open the pipe, and then start listening. I believe there's a start listening and a stop listening functions that are in the library. You start listening, and then I set my things, set up runs, the meat of the code. Alright, so if radio available, boolean done is false. Okay, so while not done, do this. So these are, I'm starting a millis clock in here, because what I'm doing is I'm taking I believe I have it set for 100 milliseconds of data, and then I'm averaging that data. That's basically just to get out a form of filtering, make the signal a little more usable and a little steadier flowing. I have a couple of different values, and then another while loop. So while millis minus start millis is less than the sample window. So start millis is I believe what I have, or sample window I have is what's set to 100. Millis is a time, and so this is just where I'm taking my 100 millisecond data samples, and then I'm doing some things to them. This is using the same thing as up here. It's just getting the values from the sensor. So radio.read sensor size, and it's putting it into that array. Sample equals sensor, so that's just to change the value, and this is where I'm doing my math on it to get out the average values basically. So I'm narrowing it down from both sides. Peak to peak is equal to the signal max minus the signal min. Double volts. This is just the math that needs to be done in order to convert it into volts. You got to take it, multiply by 3.3, divide by 1024. These are just some troubleshooting lines that I had in there trying to figure out where my numbers were going and everything. And then I just have a bunch of logic if-else statements where I set some thresholds that light LED pins. So, obviously the first one lights one LED, sets the rest to low. The next level, 2 LEDs, sets the rest to low. And then so on and so forth until the last one is all of the LEDs are on. That's the highest level, and then otherwise they're all low. Then there's this else statement down here, whereas if I'm not getting any radio data, if I'm not getting a transmission, it'll send no radio available. That just lets me know that either I'm outside the range and the radios are no longer talking to each other, or I can't go through a steel wall, or whatever it may be. And that's really it. So my contributions to this code were pretty minimal. There were these logic statements here, and I had to change a few things. I added the math in here for the sample window where I'm taking data for the 100 milliseconds and kind of averaging it so that I can, it's more usable data. It's not jumping all over the place and things like that. Alright, so that's it. I hope you enjoyed it. If you have any comments, post them below. and have a nice day.